Here's some code that simulates a coin toss, in fact an experiment that involves 10 trials. And I might just quickly step through the code together. So the first line here basically sets up the random number generator in the computer. And we start off by letting the number of heads equal 0 and the number of tails equals 0. And we're going to run an experiment of, it consists of 10 trials. And this is the loop then that runs through each trial. Okay, so basically, because of how fast the computer works, I've had to slow the simulation down so you can actually see what's going on. But basically, if the random number function, which is this one here, RND, if that actually produces a random number between 0 and 1 inclusive in decimal. So if basically if the number of if the random number generated is greater than or equal to 0.5, then we're going to interpret that as tossing a tails. Otherwise, we're going to increase the number of heads by 1. So this line here keeps track of basically how many heads or tails in the experiment of 10 coin tosses. And then each time a trial is completed, the program will update the number of the trial number and the number of heads and tails that have resulted from each trial, and then basically we'll go through the loop 10 times, and then the sleep says basically just wait for a key to be pressed and it can run the simulation again. So let's run the simulation now, and let's see what happens. So this is an example of experimental probability, okay, or relative frequency, okay. We can use software to help simulate that. So I'm just going to start the program, okay, and it's already done one simulation. So it's done 10 trials, and we've had 3 heads and 7 tails. So now we're going to just run the simulation again. You can see that this time around we've got 50-50, so 50% of each, so 5 heads, 5 tails. Run it again. Okay. You notice that each time the simulations run, there's a different number of heads and tails. It's not always exactly 5 heads, 5 tails every time. Okay. Sometimes you may get the same outcome several times in a row. Sometimes you may get 5. This particular simulation, there were 9 tails, 1 head. That doesn't mean that the simulation is biased or flawed in any way. That's just the law of probability. It can happen. There's a small chance that it can happen. What we'll do now is that let's run the experiment though, but let's now increase the number of trials. So let's make it, let's say 10,000 trials, and see what happens. Now this is going to run a little bit faster. Okay, so you're probably not going to see the individual outcomes one by one, but there's the first experiment of 10,000 trials. We've achieved 4,974 heads and 5,026 tails. Let's run it again. Okay, you can see that it's very close to 50-50, 50% of each. Okay, very rare to get, for example, when you're running the simulation 1,000 times, or a simulation of 1,000 or 10,000 or even 100,000 trials, to get, for example, 10,000 heads and 90,000 tails. Run it a few more times. Okay, you can see the numbers as they come up, the number of heads and tails. It's pretty close, okay, like I said, to about 50% of each. Okay, maybe one more. Why don't we increase the number of trials again? Okay, and instead of 10,000 trials, let's make it 1,000,000. And that's the beauty of computer simulation, that to do this by hand or manually, it will take you, it just won't be practical. Okay, so just takes a few seconds for the software to start up. Here we go. So it's actually going very, very fast now. Hopefully we'll get through 1 million. In fact, it's going so fast that you're not able to even see the the numbers as they update on the screen. So that's after 1 million tosses of a coin. You can see that if you had to round it to, say, 3 significant figures, you've pretty much got 500,000 of each. Okay, so that's after 1 million coin tosses. So I think that's actually quite impressive, and it's actually good to note. You can run a very cut down version of this simulation if you use your calculator. There was a video that I had produced earlier which shows you how to use the ranint function to generate random numbers. So you could simulate, for example, 100 coin tosses. So in some of the questions that you'll be given, you can actually run a basic simulation on your own. Or if you do know a little bit of basic programming, the software that I've used is called QB64, and I'll bring up the code again. Okay, there's the code again if you want to have a look, and it's very simple, very straightforward.